Solubility rule. Solubility rule is the rule that we deal with a lot of ionic compound. Ionic compound. On our early session, we learned, is ionic compound soluble in water? We say yes, like NaCl soluble in water. But actually, there is a lot of ionic compound that are not soluble. So student, we're going to talk about this solubility rule more detail so that you understand more of the ionic compound soluble or not soluble. Ionic compound, when you see a piece of iron, a positive, negative ion, you put into water. And in this situation, as you see a lot of iron, like the negative ions, now they've been surrounded by water as aqueous form. As this positive ion surrounded by water as an aqueous form. And now we're going to look on how this water break up the iron and make it soluble. See how the water molecule break up the iron to make it soluble or not soluble. Now if you blow up the picture, you see that this iron, actually, there is two attraction force. On this, there is an attraction force of the water towards this positive ion. Okay, remember water have a very strong hydrogen bond, that is a very strong attraction. So they try to pull this ion up and make it soluble. But there is another attraction force come from the negative ion, the partner. And this negative force, they try to put it in to stop it from dissolving and make it into one pieces of salt. So in this situation, it shows you actually there is two sets of attraction force. They are in competition, one against the other. And if one part win, it will be soluble, or the other part win, it will be insoluble. And now I'm going to look onto this two scenarios. In these two types of ionic compound, look at the ones that is soluble in water, the other one is not soluble in water. Why? Look at this picture, the soluble in water. And now in this situation, the water have a very strong attraction to this ion. And this ion showing they have a weaker attraction to this ion. So in this case, when water demonstrates to have a stronger attraction, water will be able to break this ion apart. So when when water have a stronger attraction over the negative ion, which have a weaker attraction, water win, and it will become soluble. And look onto another situation, those insoluble in water. Now in this situation is opposite. Of this ion, water try to attract it, but the negative ion is stronger on the attraction. They have a stronger attraction, and water would not be able to break this ion up, and so this ion will stay together as one pieces, and this is insoluble in water. So even they both are ionic compound, one is soluble in water, another is insoluble in water, as an example of calcium carbonate. and why, and how I'm going to tell soluble or not soluble. The clue is, in case if this is a 1 positive, if this is 1 positive, 1 negative, like NaCl, the attraction force water will be stronger. The water have strong hydrogen bond. They can break this up. But in case if the ion is 2 positive, 2 negative, in that case, like calcium 2 plus, carbonate 2 minus, in this case, this bond, the attraction force, this positive negative attraction force between ion will win the water attraction, win over the water attraction. So water cannot break it up as ion. So, but is it absolute the case? Not really. There is a lot of exception too. But general, you can guide by this rule to give you the clue. So now you start to see this ion's charge does take a part to affect is soluble or not soluble in water for ionic compound. Now let's look back onto this chart, and you, as the earlier clue, you will realize on the top group, those 1 plus and 1 minus, and you expect they will be soluble. You will expect they are soluble. Yes, they are soluble. When you come to the middle group, they are 2 plus, 2 minus, and yes, this 1 minus, as I say, there is an exception. And in this case, they are less soluble. And some of them are even less soluble, even more insoluble as to this group. So student, I show you how this group work. Now let's give example. NaCl, would they be soluble? The soluble positive have a soluble negative partner. They are soluble. Calcium sulfate, would they be soluble? They are not soluble. Why? You have the attraction force too strong. Lead carbonate, would it be soluble? As you expect, they're even less soluble. They're not soluble. So in this case, the situation would be more complex in case if they have other group. And now let's see. Let's take carbonate as example. They are a very insoluble substance. If I mix it with calcium, would you expect it to be soluble? No, they're not soluble. How about if I want to mix it with K? Yes, you have a more soluble partner. Now it helps. So now this sodium or potassium carbonate, now it becomes soluble. Take sulfate as example. Would sulfate be soluble? It is very much in the middle group. Depend what partner now. If you have a Pb, would you be soluble? No, you're not soluble. Then how about if you have a K or Na, will you be soluble? Yes, you will become soluble. Take PB example. They're very insoluble. Would this be soluble? No. Would this be soluble? You thought yes? Still not good enough. This PB, they are very, very insoluble. How am I going to deal with it to make it soluble? The only way is now PbNO3. They are the most soluble partner. You can deal with this very insoluble substance. So you can see on the top of the top, I put NO3 separate with this line because they are super soluble group. Super soluble group. So student, I hope you try to, besides you learn the charge that earlier I told you, and please learn the solubility rule, or at least try to pay attention to those least soluble compound, the less soluble and the insoluble compound, because that it will help you on the next section. I'll show you. Now we're going to make use of this chart. On the top group, the soluble group usually are the 1 plus 1 minus. Now we look onto the less soluble. I put the lighter color means medium, the darker color more insoluble, as Mg2 plus medium soluble, Ca2 plus medium soluble, Ba2 plus medium soluble. Student, please make an effort to remember. Ag1 plus very insoluble, Pb2 plus very insoluble. Now let's look onto the negative ion. OH1 minus, medium insoluble. SO4 2 minus, medium insoluble. Then go to the more insoluble. Carbonate, very insoluble. PO4 3 minus, very insoluble. This 4 is those insoluble group. So you have 5 positive insoluble group and you have 4 negative insoluble group. And student, please make an effort to memorize of those insoluble ion, and that will help you to do the following. When you have mixed ion together, would they clump together? I give you example. CaCl2 and KCO3. In this one, CaCl, which one is the less soluble compound? Ca. Ca is here, Cl is here. Ca is less soluble. Now KCO3, KCO3 and CO3 are less soluble. So you expect if you put these two solutions together, something will clump together and we call precipitate. So those less soluble group, so the Ca and the CO3, they are less soluble, they will be clumped together as precipitate. So student, please try to remember those less soluble ion so that you will know what will clump together, as important for you to do the solubility rule. Now let's continue. BaCl, which one's less soluble? NaSO4, which one's less soluble? So they will clump together. Next, which one's less soluble? Ag. KCl they both soluble. But I know Ag is a plus, so it will only marry with the minus Cl. Remember, ionic compound, positive ion comes first, negative ion comes second. The next one, PbNO3, NaCl. Which one's less soluble? Pb. So what would you expect something will precipitate? Next, which one's less soluble? NaCO3 and AgNO3? And they will precipitate. Next, precipitate. And student, please try to do the next session to see if you get it right. The point is, please remember those less soluble compound, so that it will help you to know the precipitation.